They brought the American tank to Kummersdorf to learn where to shoot it. By the end of the first week, the German engineers were no longer studying its armor. They were studying the fact that it had crossed more than 200 miles of North African desert, started on the first push, and could be kept alive by an ordinary mechanic with ordinary tools. The M4 Sherman was not the strongest tank Germany had ever captured. That was the problem. It did not need to be. In the spring of 1943, a captured Sherman arrived at the German army proving ground south of Berlin, still carrying pale Tunisian dust in its suspension. The men waiting for it knew exactly what they expected to find: American mass production, crude shortcuts, thin armor, a machine assembled quickly, because the people who built it did not understand the art of tank design. German armored engineering had produced the Tiger. The Panther was entering service. On paper, both could outgun the Sherman. Both carried thicker armor. Both looked like the future of armored war. The American tank looked almost ordinary. Then a mechanic climbed into the driver's seat. The engine fired at once. No long ritual, no careful warming sequence, no team of specialists listening for the wrong metallic note. The 9-cylinder Continental radial settled into a steady idle while the evaluators stood in the cold and waited for the problem to appear. It did not. One engineer walked to the rear deck and listened. The engine had already survived the retreat from Kasserine Pass, capture by German troops, and a road march of more than 200 miles to Tunis. It had done that without a major mechanical failure. Now, after rail and sea transport, it started as if it had been parked the night before. That was the first moment the room changed. The Germans had captured the tank to measure how easily it could be destroyed. Instead, the tank began explaining how a war could be sustained. The engine compartment opened through broad, counterbalanced hatches. The spark plugs were visible. The oil points were reachable. Filters could be removed without dismantling half the vehicle. A field mechanic could perform routine work with tools he already carried. The design did not ask, "How much performance can we force into this space?" It asked a colder question. "How quickly can this machine return to the fight?" The distinction mattered. A Panther's Maybach engine was powerful, compact, and sophisticated. It was also buried inside a crowded mechanical system that punished mistakes and demanded trained hands. A failed ignition component could turn a combat vehicle into a workshop problem. A Sherman could often be serviced beside a road. A Panther frequently had to be recovered, hauled, opened, and repaired by men who might be many miles behind the front. The German engineers knew how to build extraordinary machines. The Americans had built a machine that expected to be dirty, tired, damaged, and far from home. That was not inferior engineering. It was engineering for a different war. On the 6th day, the test team examined the transmission. German tank crews were accustomed to noise, gear whine, heat, the hard mechanical scream of components carrying loads close to their limits. The Sherman's transmission produced a low, controlled hum. Inside were precision-cut double helical gears, expensive to tool, difficult to mass-produce, and smooth under load. Germany understood the principle. What it lacked was the industrial freedom to put that level of production into tens of thousands of vehicles. The Allied blockade had tightened access to strategic materials. Machine tools were already serving too many programs. German factories were building several families of tanks, guns, engines, final drives, and specialized parts at the same time. The Americans were doing something brutally simple. They were standardizing. They were building the same useful components again and again, in plants designed to repeat the process, with workers trained to produce parts that fit the next tank, and the next, and the next. The Sherman's welds carried the same lesson, not the romance of a master craftsman shaping one perfect machine. The discipline of a factory making the 10,000th machine as usable as the first. That kind of consistency looked unimpressive in a photograph. On a battlefield, it meant a replacement transmission arrived and actually fit. It meant a mechanic did not have to reshape a component by hand. It meant a damaged tank could return before the front moved on without it. Then the engineers opened a small metal housing beside the gun mount. Inside was a gyroscopic stabilizer. The Sherman's 75mm gun was not designed to fire accurately at full speed, but the stabilizer helped keep the weapon near its aiming point while the hull moved. When the driver stopped, the gunner did not have to wait as long for the tank to settle. In a duel measured in seconds, that mattered. German tanks had excellent optics and powerful guns, but their crews usually had to stop, let the suspension settle, find the target, and fire. A trained Sherman crew could halt with the gun already close to where it needed to be. The advantage was not dramatic enough for a parade ground. It was exactly dramatic enough for the first shot. The evaluators understood the device. They also understood what it represented. Precision electrical components, reliable servos, miniaturized manufacturing, a supply chain capable of placing the same system into vehicle after vehicle. The gap was not imagination. The gap was repetition. Germany could design advanced equipment. America could manufacture advanced equipment until it became ordinary. That summer, senior officers watched the captured Sherman and a Panther attempt a mobility demonstration. The Panther climbed a loose sandy slope cleanly, its broad tracks gripped, its engine pulled. At the top it looked every inch the superior tank. The Sherman tried next. Its narrower rubber block tracks spun. The hull slid backward. The American tank failed the hill. The officers saw what they had come to see. The Panther had conquered the obstacle. The Sherman had not. But one engineer was looking past the slope. Behind the reviewing stand sat the rail cars that had carried the Panther to the demonstration. The Panther had been shipped because its early final drives could not be trusted over long road marches. The Sherman had driven to the test ground under its own power. Dozens of miles on ordinary roads, no recovery tractor, no rail schedule, no special preparation. It had failed the hill and still exposed the larger truth. A tank does not win a war by climbing one slope. It wins by reaching the next slope and the one after that, and the one after that. This was the idea German procurement struggled to accept. The Tiger and Panther were designed around decisive local superiority, thicker armor, longer guns, more power, the ability to destroy an enemy tank before that enemy could destroy them. In an isolated engagement, that logic could work brilliantly. German crews proved it again and again. A well-positioned Panther could kill Shermans at ranges where the American 75mm guns struggled to answer. A Tiger could dominate a road, a field, or a village approach. But armored warfare was not one duel held on clean ground. It was fuel, tracks, bridges, rail cars, recovery vehicles, spare parts, mechanics, drivers, replacement crews. A machine that could move on Monday, fight on Tuesday, be repaired on Wednesday, and move again on Thursday. The Sherman had been designed inside that system. The Panther often behaved as if the system existed to serve the tank. By the summer of 1944, the argument was no longer theoretical. In Normandy, German crews fought from some of the most dangerous armored vehicles in the world. They also spent enormous amounts of time beside them. A Panther could be tactically alive and operationally dead. No shell penetration, no burned turret, no shattered crew compartment, just a failed final drive, a broken transmission, or a damaged component that could not be replaced before the unit had to withdraw. When the front moved, crews placed charges inside tanks that had never been knocked out. Then they walked away. On one road south of Cannes, a Panther crew could watch an American column pass on a parallel route. Shermans, half-tracks, fuel trucks, jeeps, recovery vehicles, more Shermans. The American vehicles were not invulnerable. They broke tracks, they threw rods, they burned when hit. Their crews died in terrible numbers. But the column kept moving because the system behind it expected loss and had already prepared the answer. A replacement tank did not have to be perfect. It had to arrive. A spare part did not have to be handcrafted. It had to fit. A mechanic did not have to be a factory specialist. He had to know the procedure. That difference consumed German strength without producing a dramatic battlefield moment. There was no single explosion called industrial defeat. No one day when the German armored force stopped existing. Instead, readiness leaked away. One tank waiting for a gearbox, another waiting for a tow, another cannibalized so two others could move, another abandoned because the recovery unit had no fuel. On paper, a battalion still possessed its tanks. In reality, fewer and fewer could answer when the order came. American armored units often kept a far larger share of their vehicles operational. German formations frequently reported strength that existed only in ledgers. A division at 40% readiness is not a division. It is a repair yard with guns. The Ardennes offensive in December 1944 made the lesson impossible to hide. Germany concentrated Panthers, Tigers, and King Tigers for one final attempt to split the Allied armies in the West. The attack achieved surprise. German armored columns smashed through thinly held American lines. For several days, they moved with the violence of an army that had found its old strength. Then the roads narrowed, traffic jammed, fuel disappeared. The heaviest vehicles consumed enormous quantities of gasoline simply to remain part of the advance. Joachim Peiper's battle group pushed deep into Belgium, captured American fuel, and kept moving until the supply problem caught it. When the column stopped near L'Église, many of its tanks were still dangerous. They were also stranded. The crews destroyed vehicles worth months of labor and walked out through the winter woods. Not because every tank had been defeated in combat, because the system could no longer carry them. Meanwhile, the American system bent, lost ground, absorbed the shock, rerouted supplies, repaired vehicles, and pushed back. Shermans returned to the roads, fuel trucks returned behind them, recovery crews pulled damaged tanks away. Replacement vehicles arrived from depots connected to ports, connected to shipyards, connected to factories an ocean away. The individual Sherman could break. The machine behind the Sherman did not stop. That was what the German evaluators had seen in 1943, even if the conclusion was uncomfortable. The captured tank was not a masterpiece by conventional German standards. Its armor was not the thickest. Its gun was not the most powerful. Its silhouette was high. Its early ammunition stowage could be dangerously vulnerable. It had flaws. But it functioned under field conditions. It tolerated average crews. It tolerated imperfect maintenance. It tolerated long road marches. It tolerated the kind of war in which dust entered every seal, schedules collapsed, trained men disappeared, and the nearest proper workshop might already be behind enemy lines. The design assumed reality would be cruel, so it made recovery, repair, and replacement part of the weapon. By the end of the war, the United States had built 49,234 M4 Shermans. Germany built roughly 6,000 Panthers and 1,347 Tiger I tanks. Those numbers alone did not decide every battle, but they decided what happened after the battle. A German crew might destroy several Shermans and survive. Then their own tank needed a part. The Americans returned the next morning with more vehicles. The Germans returned when the repair was finished. Sometimes it never was. In Detroit, Grand Blanc, Lima, and other American plants, armor plate moved through fixtures designed for repetition. Engines arrived from existing industrial lines. Components were standardized. Changes were introduced without stopping the entire flow. The goal was not to create one tank that made engineers proud. The goal was to create an armored force that commanders could count on. A tank ready today, a replacement ready tomorrow, a part ready when both of them broke. That is why the Sherman is so easy to misunderstand. It is judged as a machine standing alone, gun against gun, armor against armor, tank against tank. But the Sherman was never alone. It arrived with fuel, with mechanics, with spare tracks, with radios, with recovery vehicles, with factories still producing, with ships still crossing, with railheads still unloading, with another Sherman already behind it. The Tiger was a weapon. The Panther was a weapon. The Sherman was a working part of a system designed to continue, and continuation was the one contest Germany could not win. In the final months of the war, German officials could read the production tables while artillery moved closer to Berlin. The numbers no longer described a future. They described an ending, fuel output collapsing, rail lines broken, factories dispersed, skilled workers dead, drafted or exhausted, armored units reporting vehicles they could not move. Across the front, American crews were still climbing into Shermans, pressing the starter and hearing the engine catch. Not every time. No machine earns that myth honestly, but often enough, fast enough, with few enough specialists, across enough roads, for enough months. Germany built tanks that could win extraordinary moments. America built a tank force that could survive ordinary days, and wars are made of far more ordinary days than extraordinary moments. The Sherman did not have to be the best tank in the world. It only had to start, move, fight, come back, and do it again. That was not good enough. That was the whole point.